All right, so when we talk about these models, the one that we're going to focus on a lot tonight is the OSI model, the Open System Interconnection model. And like I said, this is just a way of describing, and that way also we have a common language of talking about the network. So that way everybody knows what we're talking about. And when you get in the field, you're going to hear people talking about layer 2 devices, layer 3 devices, physical layer devices. That's what they're talking about. It's based on this OSI model. And in week 1 in your assignments, there's more to that. So with this model, we can start at the top or at the bottom. I'm going to start at the top and work down, or you can start at the bottom and work up, but it doesn't matter. But it's 7 layers: application, presentation, session, transport, network, data link, and physical layer. And we're going to get into each of these layers a little deeper tonight. What I like to do is break this thing into 2 parts. You know, it's just 7 layers, but I always break it into 2 parts. The top 4 layers, layer 4 through 7, and then the bottom 3 layers. So at the top layer, at the top area, is those first 4. And like I was telling Nicole, this presentation is going to be online. It's going to be in your syllabus. It's going to be in the Canvas. So I will post this online so you can go back and watch it again. And I'll put the PowerPoints out there as well. Okay, so at the top layer is what we call the application layer, then the presentation, session, transport. These are the layers that really works closely inside of your computer, inside of your operating system. A lot of these things we call protocols, and these things, what's in parentheses, that's italics, those are protocols. Now, what is a protocol, you may ask? I'm sure you're thinking that. A protocol is just a way of talking. It's a common language for things, for entities, for people to talk to each other. You know, everything follows some type of protocol. If, you know, I'm going to use 2 very abstract examples here. Since Naki, you're Vietnamese, and your heritage is probably different than mine. So if I went to your family reunion, there are probably protocols that I would have to look at. Oh wow, how do I sit? What do I eat? That's different than if you went to my family reunion. If you went to my family reunion, you're gonna see Ray Ray and Junebug and all of them out there acting crazy and stupid, talking real loud, drinking Coke 45. You might not see that at your family reunion. I don't know. Well, I don't know. They might. But either way, that's a protocol. Okay, how do I act? How do I respond in that environment? That's what we call a protocol. Well, within networking, the same thing. Protocols are what allows devices to talk to each other. So for your computer to be able to see this video, it has to have a known protocol between your computer and my computer. If the protocols weren't the same, you wouldn't have been able to dial in. So that's all we're talking about when we talk about protocols. But protocols are the heart of our network. I mean, that's what makes everything run together. And we're going to get a little deeper into each of these protocols throughout the week. So let's look at this first layer. Layer 7, application layer. Now, the application layer is the layer of protocols that allows your computer applications to work. First thing I'm going to say, please do not confuse this layer, layer 7, with user applications. And here's what I mean. On your computers at home, I'm sure you probably have Microsoft Office, you know, PowerPoint, Word, Excel. You probably got Adobe. All of these things are user applications. This layer is not that. This is a layer that allows those user applications to work. Here's what I mean. If I were to tell you that Microsoft Word or PowerPoint cannot print, would you believe me? Yes, I know you think that's a trick question. I'm not going to answer that one way or another. They can't. And here's why. They don't have the ability to print. What they have the ability to do is when you hit the little print icon or Control P or whatever you want to do to print, it sends a message to a protocol called LPD, Line Printer Daemon. That is what within your operating system. That's what causes your printer to print, that line print daemon. Microsoft Word, any Office products itself cannot print. It has to talk to a protocol or to what we call an API, a programming interface or like a driver, and that goes to your computer to print. Likewise, Outlook can't send emails, or Gmail, any of those mail programs, they cannot send an email. They can format an email. Now, after they format it, they send it to a protocol called SMTP, Simple Mail Transfer Protocol. That's the protocol that actually takes your email and puts it out onto the internet and routes it to where it needs to go, SMTP. So that's layer 7. Layer 7 is the application programming interfaces that's in your operating system that allows your applications to work. Internet Explorer, another example. Internet Explorer, or let's say if you use Google, Chrome, if you got a Mac, you may use Safari. They cannot get you to the internet. HTTP, Hypertext Transfer Protocol, is what does that. Now, what those applications do, when you want to go out and do a search on it, you go to a website, Internet Explorer or Bing or Chrome, any of those, they call up this protocol, HTTP. HTTP now takes that information and puts it out there on the internet for you. So that's the application layer. The application layer is, like I said, those are application programming interfaces in your operating system that allow your user applications to operate. And they're the ones I have over here on the right side. These are just representative. There are tons of these. Okay, let's go down to layer 6. Layer 6. Now, let's say if you're going to send an email, all right, you've got Outlook, you've got an email, and you've pushed it from layer 6. Then it's going to go to layer 7. From layer 7, it's going to go down to layer 6. And what layer 6 does, it formats data in the right format so that the person at the other end can get it. For instance, if I'm going to send a picture, layer 6 is what knows that this picture is going to be a JPEG, or if it's going to be a PNG or a TIFF file. That formatting is at layer 6. Likewise, if I'm going to do some encrypting or compression like zip, if you're going to zip a file, I'm sure you guys are familiar with zip. You can zip a file. Well, that's a layer 6 application or function to do that compression. I do, like I was talking to you, probably, I do a lot of music and video stuff. I use a layer 6 function called MIDI, musical instrument digital interface. So that way, when I send a picture from me to your computer's layer 6 knows that, oh, this is a PNG file. I know how to unpack it, unencrypt it, and how to present it to the application layer, to layer 7. A lot of different protocols there. Like I said, we talked about MIDI, JPEG, movies, MPEG. All those are layer 6 protocols. Layer 5. Layer 5 is what we call a session layer. Session layer. Now, what it does, it builds and terminates sessions between applications. So let's say, for instance, I have on my home network multiple computers, and they all want to use the same printer. Well, layer 5, is what builds a session so that I can share that printer. And once the print is completed, it terminates that session. So it'll build the session, means that it'll make the contact to the printer. Once the print job is finished, it tears that session down. So that's layer 5, some of the different protocols. And I say, don't worry about it if you don't recognize these protocols right now. That's really not important. These are just some examples I'm giving. There's a couple of assignments you got this week that you'll get a little bit deeper into some of these protocols, okay? But so that's what layer 5 does. Layer 5 really does build sessions. Now, layer 4, interesting layer. Interesting layer. Now, I will tell you this, those upper layers, from an IT perspective, from a networking, we don't get involved in those a lot. You do from a cybersecurity perspective, but from a networking, those upper 3 layers, you really don't get too much involved in. Now, we get to layer 4. Layer 4 gets a little more interesting because now we're getting to the things that has to do with transporting our information, putting it in a format that is able to be transported. Okay, let's say if you were, you know, if you're like me, you got multiple things open up on your computer at one time. You got internet, you got your email, you got other applications running, and all that data, you may be trying to get back and forth across the internet with it. Well, the transport layer is what takes all that data and breaks it up into segments or chunks so that it can be sent across the internet. I use it now as of a train. Let's say if you're in West Virginia where they have coal. They got this big pile of coal they want to get from West Virginia to Charlotte, North Carolina. And they want to do it by train. Well, how do they do it? They have a train that has all these box cars, and they put a certain amount of coal in each box car, and that train transports it. The transport layer is very similar. It takes all that data that's coming from all these other applications because it just sees it as a line of ones and zeros. It breaks these up into segments, and these segments are all the same size segments, and it also numbers them. It puts a sequence number on these segments, and now that data now is ready to be transported. Now it's ready. It's getting to a place where now I can transport it. Two protocols we're going to talk about quite a bit: TCP and UDP, Transmission Control Protocol, User Datagram Protocol. Those are the two basic protocols that's used across the internet to carry all of our traffic back and forth. TCP and UDP. Now, these are protocols that, yeah, you definitely want, if this is something you're going to do as a career, you need to be familiar with TCP and UDP because they are used everywhere. They are used we're using UDP right now to do this, this Zoom session. Now, but like I say, but both protocols, and we're going to get deeper into these protocols later on. This is just kind of an overview introduction. But both protocols do the same thing. It breaks up data into segments, and now, and it's able to track those segments. Very similar to our U.S. mail system. Let's say if you order something from Amazon, like a weight set, you know, because I'm sure Nicole is like, you know, there's like a fitness guru, and she's probably bench curling right now, you know, underneath the camera. But if you bought a weight set, they couldn't ship that weight set in one box. It's probably going to be 4 or 5 boxes, right? So they would label each box 1 of 5, 2 of 5, 3 of 5, 4 of 5, 5 of 5. And that's how they would ship it out. And when you received it, you would know that, hey, I'm supposed to got 5 boxes. I got 1 of 5, 2 of 5, 3 of 5, and 5 of 5. I didn't get 4 or 5. So what are you going to do? You're going to call Amazon back or email them back. Hey, I'm missing a box. That's exactly what TCP does. Transmission Control Protocol. When you send an email or you send whatever, let's say email, let's keep it simple, with an attachment. Well, TCP breaks that up into a segment. And that email, let's say it may be 100 segments that it breaks it up. And you know what? The good thing about it is that when it goes out across the internet, those 100 segments may go all different paths. Just like Amazon, when they ship your weight set, 3 boxes might go on this truck, 2 boxes may go on that truck. You don't care because they all show up at your house at the same time. That's what happens at layer 4. TCP sends these things out all over the place. Now, when I receive that email, my computer knows that because TCP told it up front. I'm sending you 100 packets, 100 datagrams, or 100 segments. And my computer starts to count them. Okay, I got 100, but let's say if it missed 97 of 100. It's going to send a message back to your computer that says that, hey, I did not get packet 97 of 100, and your computer is going to resend it. That's why it's called a protocol that has assured delivery, meaning that it guarantees delivery, just like registered mail. UDP, on the other hand, UDP is like junk mail. If you think about the U.S. Postal System, junk mail, they don't care if you live at the house or not. They're going to keep sending that stuff to you. Unlike registered mail where you sign it, another person signs it. UDP, User Datagram Protocol, that's what it does. It doesn't keep track of the sequence numbers. It's just going to send it. If a packet doesn't make it, it falls on the floor and doesn't matter. But we use this is a very useful protocol for what we're doing now with video or voice over IP. Because if we tried to use TCP for video, for streaming, it would be too slow because it's trying to go back and do that handshake and check that for every packet. And our video would be like this. It would be broken up. UDP lets things stream for streaming. If a packet drops out, all you may see is a short glitch on the screen. It doesn't matter. Unless you lose too many, then you start pixelating. But otherwise, it doesn't matter. So those are two very useful protocols that we use all the time, every day across the internet at layer 4. Now, any questions? I know I gotta get on a roll here, start moving pretty fast. But if you have questions, please, ping me and stop me. Okay, let's talk about the bottom 3 layers. Now, these are the 3 layers, especially from an IT perspective, that you're gonna really get involved in. Layer 3, the network layer. Layer 2, the data link layer. And layer 1, the physical layer. These are the layers you can physically see in your house, in your home network. All right, layer 3 is what we call the network layer. What it does now, it takes those datagrams from our segments from layer 4, and it puts a header on it, and it does the addressing, so that now it knows where to send it across the internet. That's where all your addressing is done. You probably heard of IP addresses. Well, this is where IP addresses originate, is at layer 3. At layer 3. That's where, so I'm going to get into an analogy a little bit later, so I won't cover that now. Just remember, layer 3 is where we do IP addressing. So, and now we know how to route information. Here again, keep the U.S. mail system in the back of your mind, because if these terms they start sounding the same, because they should, because they route mail every day. How is mail routed? Based on a address, not an IP address, but your physical address. There's several protocols. I'm not going to go into these protocols, but these are just an example of some of the protocols at the networking layer as we're dealing with IP. Okay, layer 2 is what we call the data link layer. Layer 2 is where we build LANs, local area networks. And layer 2 is what we are able to connect your local devices to. On your home network, you probably have we call it a wireless router, but believe me, it's more in that box than just a router. There's actually a layer 2 switch device. But that's what connects up all of your home, your computer, your cell phone, everything you walk in the door and it connects to your home computer is being connected at layer 2. And also layer 2 starts preparing the data to be sent across whatever medium it's going to go across, which is at layer 1. Layer 1 is the physical layer. That's where you got your fiber optic cable. That's where you got things like 4G, your cell phone. That is the transmission path itself. And that's where layer 2 uses protocols like Ethernet to start converting all that data into electrical impulses or light or into radio signals. That's the medium that it goes out. So that it could be sent across copper cable, it could be sent across fiber optics, or it could be sent across RF, radio frequency waves. So layer 1 is the physical layer. So layer 1, layer 2, layer 3, like I say, those are 3 layers that you're really going to be more engrossed in with respect to this class, more so than the upper layers.